Ciao, Emanuele.
Hi, good morning.
Hello. Hi. How are you doing?
Fine, thank you. And you?
I'm great. I'm great. Welcome to us. Thank you for joining us. The topic you will discuss today is, I think, very hot and very important because we see more and more encrypted traffic also in OT environment. From the point of view how to monitor this is a challenge. But you in Nozomi Networks, you have a solution. Am I right?
Yeah, that's correct. We will cover the topic, and we will have a look at the standards that are dealing with this topic. That for sure it will be interesting, and it will come in the future. So it is better to be prepared today.
Okay. So Emanuele, I'm giving you the word and start with the presentation.
Yeah. Okay. Perfect. Thank you very much. And first of all, thank you to Smartcom for giving me the opportunity of being here. It's a pleasure, and it's a honor for me. Just a few words about me. So who am I? I am the technical sales engineer in Nozomi Networks. And I started when industrial networking and automation weren't trendy. And I have a past in the oil and gas industry and in a pure automation vendor. And today I am covering the technical sales aspect in pre-sales activities in Nozomi. So few words about Nozomi. Who is Nozomi and what we are doing? Actually, we are providing a system that is aiming to provide visibility to our customers. So it is very extremely important for our customer to see what is present and connected into the existing network, because this is the first step in order to start talking about security. When we have a complete overview of what is currently connected into the network, then we can start doing detection and we can start protecting a system. And obviously, in some cases, we need a system that is able to scale, because we can have in the industrial control system maybe systems that are widely deployed on a wide area. And that's the reason why we need a system that is able to scale and to provide a unified view of what is currently happening into the system, maybe even if a location is 1,000 kilometers away. So what we will cover today is the encryption in the OT world. We will start with a little bit of history, and then we will deep dive into the current status of the system. We will cover also some parts related to the standard, and we will have some attack scenarios in the standard. So we will see some use cases about what could be wrong even if we have encryption, and what are the solutions for that. So let's start with a little bit of history. At the beginning, we didn't have encryption in the industrial control system. Today, encryption is not the norm. Why that? Because if we add encryption today, we are adding additional operation overhead. So that means that we are increasing the complexity of the system, and introducing encryption poses obviously some challenges, because I need to introduce maybe some new devices. I need to change my existing infrastructure. What will happen if something goes wrong and I need to do troubleshooting in an encrypted network? So this is one of the issue. Another one is the fact that some protocols have time constraints. So encryption can introduce some delay due to the computation effort. For example, PKI is more expensive in terms of computational power than symmetric encryption. And in some cases, we are not allowed to delay a packet because we need to deliver a packet in a specific, with a maximum acceptable delay. And this is true for example, for the goose communication. So encryption in this case would not be the solution, but maybe the integrity and authentication could be enough in this specific case. And obviously, as I mentioned, troubleshooting could be much more complicated if we have an encrypted network. And these are some reasons for which encryptions today is not there. However, the world is changing. So we are having today encryption in the upper layer of the Purdue model. So we already have encryption at the level 3 and the level 4 with protocols such as OPC or PI. And over there, they are using the classical TLS implementation. On the other hand, in the lower levels, almost no encryption is used. But even if in the standards we are seeing some work done toward encryptions, and that's the reason why, for example, we have in the standard the secure Modbus that has been released. We already have, for example, for Siemens, the Step 7 Communication Plus protocol that is introducing encryption in some specific parts of the protocol. And we have a standard IEC 62351 that is covering specifically the encryption. So today in the real life, if we go on site, we will not see almost any encryption in the system, but the standards are starting introducing these kind of things. And that means that in the near future, we will have it in a reality or in a real installation. So let's talk briefly about this standard. The standard that was developed to fix some security issues related to other standards that belong to the same technical committee. For example, the IEC 61850. And the goal of this standard is to create a more secure environment, limiting as much as possible the changes of what we have today, especially in the grids, because here we need always to keep in mind that there is history behind us, and we cannot change everything from zero. So inside this standard, we will cover two different parts. The first one is the part 3 that introduces TLS over TCP/IP, and then we will discuss briefly the part 7, so the network management part. So in the part 3, what do we have? We have requirements that are introducing the TLS. So TLS is mandatory, and together with this standard, we have a technical report, the 90-2, that addresses the need of performing deep packet inspection in communication channels that are encrypted and secured by IEC 62351. So the main focus here is to discuss how to implement deep packet inspection when we have encryption. So we need to do deep packet inspection in order to monitor the network in the best possible way. But obviously, if we introduce encryption, we need to find a balance, because if we introduce TLS, obviously the good guys will lose visibility. And given that we as Nozomi, our solution is doing deep packet inspection, we need to find a way to inspect the traffic without hindering the process that we are monitoring. So how can we do that? The standard is proposing different solutions. We are not breaking encryption. First of all, it is not possible, and by the way, it is not reasonable. But we set up a kind of infrastructure in such a way that we'll be able to decrypt the traffic in order to see what we need. One of the possible solutions is to do private key sharing. So the private key is shared with a third party, in this case Nozomi, or the vendor that need to do this specific job, to allow decryption. So we are coming back to the original case. With the key, we can decrypt the traffic. The other option is to do proxy. So the solution can act as a good man in the middle, receiving traffic, monitoring, and then encapsulating to the final destination. Or in the, let me say, most complicated case, we could implement a secure session key sharing, because in some cases we don't have certificate. So, or even if we have certificate, this is not enough to do decryption, because the key is exchanged continuously. So here the standard describes how to implement the infrastructure to do that. By the way, obviously it is a standard. So the standard is providing suggestion, is considering specific needs and some specific constraints, but then obviously the actual implementation in the real life, it must be developed. What about part 7? Part 7 is not related to encryption, but it is related to network management. And in this case, the standard is defining network objects that are objects that you can query, you can make questions to these specific nodes in order to better understand what is their health status. And SNMP, for example, is one of the very well-known protocol used here. The important thing to be noticed here is the fact that we are doing, in this case, active monitoring and not anymore passive, because we are querying devices, we are making questions to our devices. And inside an ICS, in some cases, this must be done carefully and considering all the aspects and implications. So we will move now to the demo part, and we will see two different cases. The first one will be HTP hijacking. So we are in a scenario where we can imagine we have an RTU that is implementing the parts of the standard that we described. So part 3, encryption, and part 7, so network monitoring. The encryption is over there, so we are wondering how can we arm a process configured in such a way. In the first case, obviously, the certificate has an expiration date, and the machine trusts its own clock to compute what is the current time today, to compare against the certificate and to say, okay, this certificate is still valid, so I can use it to communicate. But what happens if an attacker changes the clock in the future? So the certificate will expire, and then no communication will be anymore possible. In the second case, we will imagine a malicious actor that will install a CA certificate into the system, so into our RTU. In this case, in this specific case, the attacker will not be able to decrypt the traffic because it is using a wrong certificate, but on the other case, it will be able to authenticate on the device and do actions on it, potentially changing configuration, creating issues on the RTU itself. So, coming back to the first scenario, here we can see that we have a switch that is acting as an NTP server. This is quite common in our scenarios in this grid environment. And here we have an attacker that is connecting to the NTP, and it is changing the time delivered to the RTU. The weird thing that we have here is the fact that the operator, the good one, will see potentially the issue not when the attacker is doing that, but only when the sessions are renegotiated, when the sessions are resetted. So that means that maybe you will notice the problem the day after, and this may even more complicated to troubleshoot what is currently going on into the network. What could be the solutions here? It depends on the RTU, but maybe the first possibility is to use an unencrypted communication to restore the status, if there is such a possibility, or in the unfortunate case, to go on site and do actions on the RTU. Now, let's have a look of what could happen in this case. So here we have Guardian that is the solution that could monitor the industrial network. And here we have the attacker that is launching a script in order to change the time. So the script has started. This is the time that has been retrieved by the RTU. Now the attacker is changing the time plus adding 4 years, and that means that the certificate will probably expire. And after having set the time, this is the new time. So we have a kind of time machine in the future. So the attack is done, and now the RTU is not communicating anymore with the rest of the environment. But if we have a solution that is able to monitor the traffic, that means that we are able to spot these kind of issues and to find that somebody changed the time into our network. And maybe we can even ask to the RTU to retrieve what is the current time in order to make a difference and to better understand what is going wrong here. In the second case, we are having our attacker that now is focusing on the RTU. So the attacker is installing its own certificate on the RTU, and as I said, the traffic will still be encrypted for the attacker, but now this bad guy will be able to authenticate to the RTU and to maybe change the configuration or maybe do something weird to the RTU itself. So what can we see here, and what we described the problem? Let's see how we can monitor and we can understand that this problem is currently occurring over my network. So here we have the attacker again, that he is generating a certificate. So this certificate has been generated and it is uploaded to the RTU. So the attacker is opening a connection, and then it will upload the RTU using, in this case, FTP or another protocol. The upload is done. Now the attacker has the possibility to connect to the RTU. And what can we see in Guardian? In this case, if we are monitoring the network, we can ask to the RTU. So we are in this case passive, active. So we are querying information. So we are using part 7 of the standard. We are querying information to the RTU to retrieve the certificate and to compare the certificate from the RTU with something that maybe we have stored in memory. And here we can say, oh, there is a problem because we found an unknown certificate that could be potentially dangerous, or that in this case an attacker could kick out the legitimate operator. So these are 2 examples of what we can of what can happen into an ICS environment even when encryption is used. The good news is the fact that there are solutions to spot and to monitor networks even when they are encrypted. And so we cover that today encryption is not there in the field. It will arrive in the future. It will help somehow because it will protect the information. By the way, as always in security, encryption is not the silver bullet. It is not solving all the problems because it is still possible to attack the systems even when they are encrypted, as we saw. The monitoring systems need to detect encryption-related attacks, and we showed you that this is possible with the right tools. And Nozomi Networks obviously is ready today to protect this kind of environment. So thank you for your attention and thank you for your time.